Okay, Math Model Semester 2, Study 1.21, Exponential Functions. So the key terms: compound interest is interest applied to both the principal and any previous earned interest. E is just an irrational number. When you hear irrational number, think about pi. It's just a number that continues on and on. And E has a value of about 2.71828, and it's just going to keep on going. Okay, exponential decay is a condition in which a quantity is going to decrease exponentially over time. There is an equation for it. It is A subscript T is equal to A subscript O E raised to the negative KT power. They don't really go into details later on, so here we go. We're going to tell what everything is. So A subscript T is going to be the amount of time. The amount of time. A subscript O is going to be the initial amount. T is just going to be time. And K is just going to be the constant called the decay constant. An exponential function is a function that has the form f of x. Remember, f of x is just for function, is equal to ab raised to the x power, where a and b are both constants. Those are just numbers, and x is just going to be any number. Now, just as a precaution, I know that exponential growth and exponential decay is kind of like an older topic, so I want to tell you about exponential growth to give you a little bit of background knowledge. So normally exponential growth would be a problem where they say, oh, let's say you get really, really lucky at a job, and the first year at work they pay you $8 an hour. But they tell you that your salary is going to grow exponentially. So the second year, you would have 8 times 8, which is $64 an hour. The third year, it would be 8 times 8 times 8, which is $512 an hour. The fourth year, 8 times 8 times 8 times 8 would be 4,096. Now, what that shows you is just how fast numbers can grow if you are using exponential growth. So we start at 8, 64, 512, 4,096. And of course, there's an equation associated with it. So if you were to put in your calculator, y equals 8 raised to the x power, that would be an example of exponential growth, and what you have there is the table. Alright, let's talk about decay, because it's a little different. With growth, the values increase. With decay, they're actually going to decrease. And let's say you gave a little cousin or someone $5, right? So on the first month, they have 20 cents. And in the second month, they have only 4 cents. And then in the third month, you guessed it, they have just 1 penny. And in the fourth month, they officially have nothing left. That's an example of exponential decay. And in this case, I just used the equation y equals 2 raised to the negative x power. Okay, so exponential growth is just a condition in which a quantity increases exponentially over time. Think about that salary, and if you could have gotten $8 an hour, and then it grew exponentially. So it grew very fast. So the equation for exponential growth is very similar to the equation for exponential decay. The only difference that you're going to see is that there is no negative with KT because it's positive. It's growing. And so A subscript T is just the amount that you have at that time. So AT, like the other one, is the amount at a certain time. All right. A subscript O is just the initial amount. It could be kind of like your principal amount, what you start out with. All right. K is going to be your growth constant. And that's K. And T is just going to be time. Okay, half-life is the time it takes for a quantity to decrease to 1/2 of its size. It's important that you know if a quantity is decaying exponentially, its half-life is a constant. I would make sure to write this portion right here down because it looks like a great quiz question. So hint, hint, that's important. The principle, like the other lessons, is just the amount of money invested or borrowed. The main idea in exponential function is a function where the variable is an exponent. So we're going to write base, coefficient, exponent, or function in each blank. So one word that should be kind of popular, if you see exponential and you know the title for the lesson is on exponential functions, so this is just an example of an exponential function. The value of the function depends on the value of the exponent. Over here to the right where it's pointed at the x, you know that the x is just the exponent. That is the power that we are raising the values to. Now, the coefficient is just a number that is in front of the variable, and it's any constant. So on this line you would just put coefficient, and here you would write the word base, the number to multiply by itself. All right, it must be positive, but not 1. Now, the main idea is that the two main kinds of exponential functions are exponential growth and exponential decay. Okay, exponential growth is just an amount increases exponentially at a constant rate. So it's going to increase exponentially at a constant rate. An example of a constant rate would be something doubling or tripling or just multiplying by any value. All right, and opposite for exponential decay. It's an amount decreasing exponentially at a constant rate of time. So think about that little cousin. If you gave them $5, what would happen? They're going to spend it really quickly. And an example of decay would be a half-life, a quarter life, any fraction of a of a rate. Here's another main idea. Exponential growth and decay functions have the same standard form. We're going to write amount, factor, rate, or time in each blank. So for exponential growth and decay, the function f of t is equal to a sub 0, which is just going to be your initial amount, b is going to be your growth or decay factor, K is going to be the growth or decay rate, and T is just going to be for time. So let's do a practice. The main idea to evaluate an exponential growth or decay function, substitute a value for the exponent variable and simplify. So the first example, exponential growth, says find f of 4 where f of x is equal to 3x. So what you're going to do is substitute wherever you see an x, you're just going to put a 4. So this is 3 raised to the 4th power. To put this in your calculator, you just want to press 3, And then use the rooftop, which is over here underneath clear. Press that button and then put a 4 and hit enter, and we get 81. Now truthfully, this is 3 times 3 times 3 times 3. You get the same answer, 81, but it's a lot quicker to just hit 3 to the 4th power. So your final answer is 81. For exponential decay, it says find f of 1 where f of t is equal to 2 times 1/2 raised to the 3t power. So everywhere you see a t, just substitute in a 1. So f of 1 is equal to 2 times 1/2 raised to the 3 times 1 power. So I will plug it in the calculator just how I see it. 2 times, open parentheses. To get a fraction, press alpha in green and y equal, and we just need a numerator over denominator. So it's going to be 1 over 2 and close parentheses, the exponent button right there, raised to 3 times 1, and hit enter, and you get 1/4. Now if you want a decimal answer, that's fine. Just press math, which is right here, and 2 for decimal, and you get 0.25. Either one of those answers would suffice. The last main idea of this page is that the compound interest is an example of exponential growth, and we've used that equation before. As more time passes, the amount of money grows faster and faster according to the equation below. So compound interest is a subscript t is equal to p, which is principal, times 1 plus the interest rate divided by the number of times per year raised to the nt power. So number of times per year times time. Let's go ahead on and write down all of those variables. All right, from the equation, a subscript t is just the amount of money in the account after t years. Boom. P represents the principal, the original amount in dollars that's put into the account or the amount that's borrowed. R represents the interest rate, and it's always going to be written as a decimal. The N represents the number of times a year the interest is compounded. So if it says monthly, that's 12. Quarterly, that's 4. T represents the number of years the interest is compounded. And so we're going to use the formula to solve the problem below, and we're going to show all of our work. So it says you invest $200 in a savings account. The account pays 3% interest compounded monthly. How much money is in the account after 8 years? So what's most important here is that you started out with $200. That $200 represents the principal. The account pays 3% in interest. So that's your interest rate, R, which is always written as a decimal, so 0.03 or 0.03 is compounded monthly, so our number of times is 12, and we want to know in 8 years how much we have. So now we'll just take those values and plug it into the equation. So A subscript T is equal to 200 times 1 plus 0.03 divided by 12 raised to the 12 times 8 power. All right, now we're going to plug that into our calculator. Okay, so here we go. We're about to plug it into the calculator. We got 200, open parentheses, just like it is on the problem. Plus, oh, that should be plus. And we want to get a fraction, so alpha and y equal, just a numerator over denominator, 0.03 over 12, close parentheses, raised to the 12 times 8 power. All right, and we get a total amount in our account now of $254.17. Okay, here's some things that we need to know. The main idea: as the number of interest compounding periods in gets bigger, the amount of money in the account gets closer to the number E. So let's talk about it. E is going to be an irrational number. Think about pi. Because it goes on and on forever, it's going to be rounded to 3 decimal places. The value of E is, let's get our calculator. So E has a value, any number raised to the first power is going to be just that number. So to get to the E button, right here on the side, you see where it says ln natural log. That's the opposite or the inverse function. It's going to be second, and then that button there, you have the E value. Raise it to the first power, and that's your value for E. So 3 decimal places is going to be 2.718. So it's tens, hundreds, thousands, 2 and 718 thousandths. You can approximate its value by substituting in large values for n in the expression 1 plus 1 over n raised to the n power. So right here, the word is going to be large. Now, the next thing tells us to use the calculator to evaluate each expression, and we're going to round to the 4 decimal places. So let's talk about how we do this inside of our calculator. We're not going to use those values. Instead, here's what we're going to do. Okay, and so we have to get the E button because we're doing E to the 5th power, or Euler's number to the 5th power. So you press second, and then natural log again. Right there, you get E, and raise to the 5th power, and just hit E. So it says 4 decimal places will be 148 and 4,131 ten-thousandths. All right. Remember, 5 or more, raise the score. 4 or less, let it rest. So our answer rounded up to 148 and 4,132 ten-thousandths. So let's do our next one. So we have E raised to the 2.4 power, and you get 11 and 231 ten-thousandths. Well, actually, 5 or more raise the score, so that's going to be 32. Okay, and one of the last 2 main ideas here, it says the number E helps you compute interest that is compounded continuously using the formula below. Alright, so the continuous compound interest formula just says that A subscript T is equal to the principal times E raised to the RT power. So we multiply the rate times the interest rate times the time. So A subscript T is our amount after a certain amount of time. So our amount. So it's just your amount of money in the account after T amount of years. P is going to just be your principal value. The original amount that you put in. R is going to be your interest rate written as a decimal. And T is going to be the number of years the interest is compounded. So we're going to do a practice one. It says you invest $500 in a savings account. The account pays 4% interest compounded continuously. How much money is in the account after 7 years? So we start with what's important. The initial amount is going to be $500. That's your principal. The account pays 4% interest, so 0.04 as a decimal. And we need to know how much we have after 7 years. So we just plug it in. The amount after 7 years is going to be equal to 500 times E raised to 0.04 times 7 power. All right, let's put it in the calculator. Okay, so to put this inside the calculator, we want to do 500 times E raised to the 0.04 times 7 power. All right, hit enter, and we get $661.56. Okay, and looking right here down at the bottom, this lets us know that we are done with this lesson. So if you need some help, let me know. As always, I am here for you. If your calculator does not give you the correct answer, something not right, just let me know. I am here for you. Thank you. Bye.